truly am really excited about this article because I've heard a bunch of weird things about TCP things from various people. Like one was from Guy Serino from Netflix that said if you can fit something into one packet, it's really, really fast. If it has to be split into two packets, it can be as slow as up to 20 packets. I've heard a whole bunch of different like stories around it. I was always network adjacent. Like I never was on that side of doing things. So this has always just been like a very curious, it's just a curious world to me. Having a smaller website makes it load faster. That's not surprising. What is surprising is that 14 kilobyte page can load much faster than a 15 kilobyte page. Maybe 612 milliseconds faster, while the difference between 15 and 16 is trivial. This is because of the TCP slow start algorithm. This article will cover what it is, how it works, and why you should care. This is going to be one of those good ones that I'm going to absolutely love, and I'm going to be super stoked from beginning to end. This is a sit down. I am super pumped up one. The only thing I'm not pumped up is that the font. The font makes me feel like I'm on acid. I keep waiting for it to wiggle. All right, Transmission Control Protocol is a way of using Internet Protocol to send packets of data reliably. Sometimes this is referred to as TCP/IP stack. When a browser requests your website or an image or a style sheet, it makes a request using HTTP. HTTP is built on top of TCP, and a single HTTP request is usually made up of many TCP packets. I'm curious if any of these things apply to Quick, right? Because I don't know what percent of internet traffic is HTTP 3. Oh, wow. Okay, for those that don't know, HTTP 3 is built on top of Quick, which effectively is TCP over IP or TCP over UDP in the most simple sense. So it's very interesting because that means it does not apply to. I wonder if there's some sort of thing that applies to UDP as well. I have no idea.
The Hague is issuing a subpoena to that Wiggle font for war crimes.
Oh, yes, that Wiggle font is actually a war crime. On its own, IP is just a system for sending packets of data from one location of the internet to another. IP does not have a way of checking if the packet has successfully arrived at its destination or what port it goes to, right? So one thing that's like TCP also contains the port number. I don't know which came first, port numbers being locked to 2 bytes or the TCP protocol being locked to 2 bytes that caused it. I don't know why ports always remained within 2 byte range, but my sneaking suspicion is that it's locked based on the TCP algorithm. Crazy. Anyways, let's see. When it comes to websites, knowing all the data has arrived is important. Otherwise, you could end up missing chunks of a web page. There are other uses of the web where this doesn't matter so much, like streaming live video. Correct. Because you just do GOPS and all that stuff. TCP is an extension of IP that allows a browser and your web server to tell each other which packets have successfully arrived. The server sends some packets, then waits for a response from the browser saying it has received the packet. This is called an acknowledgement, or ACK. Then it sends some more. Or if it hasn't received an ACK, it can send packets again. True. This is part of the reason why it is so slow. What is TCP slow start? TCP slow start is an algorithm used by servers to find out how many packets it can send at a time. When a browser makes a connection to your server, the server has no way of knowing how much or knowing the amount of bandwidth between them. True. Bandwidth is how much data can be transmitted over a network per unit of time. Usually, it's measured in bits per second, BS. Call him BS on this one. Plumbing is a common analogy. Think of bandwidth as how much water can come out of the pipe per second. Isn't there something called like Shannon's theorem too that describes actually how much water can come out of this pipe? Am I right on that? Shannon's theory provides the theoretical maximum rate at which information can be sent over a communications channel without errors. Okay, we'll call myself kind of right. Your server doesn't know how much data the connection can handle, so it starts by sending you a small and safe amount of data, usually 10 TCP packets. Okay, so this makes perfect sense because usually 1440 is the MTU? It's like 1500 is the MTU. But you also have to have the IP and TCP header, which is 20 bytes. If those packets successfully reach your site's visitor, their computer sends back an acknowledgement saying that the packets have been received. Your server sends more data back, but this time it doubles the amount of packets. This process is repeated until the packets are lost and your server doesn't receive an ACK, at which point the server continues to send packets but at a slower rate. The gist of the TCP slow start, in real life, the algorithm varies, but that's essentially how it works. Yeah, 1440 or thereabouts. Yeah, it seems to vary a little bit exactly how big it is. Because, like, I know with UDP, you're supposed to be, like, at a safe limit below before you put in your framing. Because there's, like, you just don't know. So, let's see. Most web server TCP slow start algorithms start by sending 10 TCP packets. The maximum size is 1,500 bytes. The maximum is not set by the TCP specification. It comes from the Ethernet standard. Wow, that's a crazy-looking link they got there. Each TCP packet uses 40 bytes in its header, 16 bytes for IP, and 24 bytes for TCP. Oh, I thought TCP was only 20 bytes. That's 24 bytes? Oh, okay. I was wrong. That leaves 1460 bytes per TCP packet, or roughly 14K. So if you can fit your website or the critical parts of it into 14K, you can save your visitors a lot of time. The time it takes for one round trip between them and your website's server. How bad can one round trip be? People are very impatient. One round trip can be surprisingly long. How long depends on latency. Latency is the time it takes for a packet of data to travel from its source to its destination. If the bandwidth is how much water can go through the pipe per second, the latency is the time it takes a droplet of water to enter the pipe and then exit the other end. Here's a fun example of how bad latency can be. Also, this is very like ASN dependent. And so depending on your region, this is actually really, really important. My website is 14 megabytes in assemblies. Oh, nice. Imagine if the Netflix website was under 14K. Dude, you just can't stop getting people to write a lot of JavaScript, okay? We're counting bytes in 2025. We should have always been counting bytes. I think that's the problem. I think that's the true problem, is we should have always been counting bytes, but we didn't. All right, satellite internet. Satellite internet is provided by a satellite in orbit around the Earth. It's used by people in very unpopulated areas, on oil rigs, cruise ships, and for in-flight Wi-Fi on airlines. Also, it's just being used more and more. You know, I've heard of Elon-Fi. To illustrate these examples of bad latency, let's imagine a bunch of oil rig bros have forgotten their dice at home and need to use an excellent under 14 kilobytes missingdice.com to play Dungeons and Dragons. Classic oil rig behavior, by the way. What is an oil rig bro? Like it is like Mario and Luigi, except for the oil rig version, which means cocaine and hookers. It's like the same thing. First of them uses their phone to make a request on the webpage. The phone sends that request to the rig's Wi-Fi router, which sends that data onto the on-rig satellite dish. Let's be nice and say that it takes 1 millisecond. Okay, fair. We'll just say we'll be nice. The satellite dish then has to send the data to the satellite in orbit above the Earth. Typically, this is achieved using a satellite in geostationary orbit at this many kilometers above the Earth's surface. Let's see, the speed of light travels at this many meters per second. Oh, I'm loving this. So a message sent from Earth to a satellite takes 120 milliseconds. The satellite then sends the message back to the ground station, which takes another 120 milliseconds. Then the ground station has to send the request to wherever the server is on Earth. Light slows down to about this much when it's in fiber optic cable. If the distance between the ground station and the server is the same distance as between New York and London, it's about 28 milliseconds. But if it's more like the distance between New York and Sydney, it takes about 80 milliseconds. We'll call it 60, a convenient number for our math. Yeah, because 120, 120, 60. Okay, I like where this is going. Then the request needs to be processed by the server, which could take maybe 10 milliseconds. Then the server needs to send it back to the ground station, up into space, back to the satellite dish, then to the Wi-Fi router, and then back again to our Oilers phones. All right, if we do the math, that's 612 milliseconds. This is an extra 612 milliseconds every round trip. Perhaps that doesn't seem like a long time to wait, but your website could easily have many round trips just to fetch its first resource. Now, one problem with that statement is that I don't know the exact number these days. I used to know the number depending on the browser. It's now totally different probably. But every browser can spawn a certain number of connections to an origin server. This is why you'll often see different resources shared on different origin servers. In HTTP, there is a connection keep alive, right? There's like a connection header that you can say, hey, connection, and then you can have, you can say what kind of behavior you want. Do you want it closed? Or do you want it to be kept alive? Since HTTP 1 and 2 are transferred over TCP, if you request a resource, you go and get it. It comes back. It responds. The next resource will not have a slow start, because it's going to be using the exact same connection to make the next connection. And so therefore, the slow start should have already happened, and you won't have it. So I don't know exactly how many will exist. I'm sure there's some sort of browser dependence here. See, also HTTPS requires 2 additional round trips before you can do the first one, which gets us up to 1836 milliseconds. Wow, 1.8. Okay, that's a lot. Dude, if you're an oil rig, bro, you're screwed. What about latency for people who live on dry land? Satellite internet might seem like a deliberately bad example. I chose it because it illustrates the point and is weird. But for the land lovers, latency can get worse than that for lots of reason. 2G mobile typically is this one. 3G networks are somewhere between here. Noisy mobile networks stay in an unusually crowded place like a music festival. Servers dealing with high amounts of traffic. If you're just on Wi-Fi and in more than one person's on Wi-Fi with you, you just get horrible service as well. So it doesn't have to be these super unusual events. Bad stuff. What is bad stuff? Spotty connections can also cause packets to be lost, resulting in another round trip to get the lost packet. Now that you know about the 14 kilobytes rule, what can you do? Well, of course, you should make your website as small as possible. You love your visitors and you want them to be happy. Aiming for each page to fit in under 14 kilobytes is a good target. Dude, with server-side rendering, I'm not even convinced that you can even make HTML within 14 kilobytes. I don't know if we got it. Guys, I don't think we got it. Let's see, all styles inlined. Yeah, no, just encode it like you did ASCII Doom. Make a new web standard. Well, the nice part is you do got gzip, so gzip actually can take quite a bit of information and pack it into 14 KB. That's 14 kilobytes included compression, so it could easily be more like 50 kilobytes of uncompressed data. I love the fact that if you said, hey, you need to make your website's landing page in under 50 kilobytes of uncompressed data, people are like, that's impossible. There's no way we could get a marketing page up without images in under 50 kilobytes. It's impossible. Dude, React isn't even 50 kilobytes. How am I supposed to have React if I can't even have 50 kilobytes? Which is generous, considering that the Apollo 11's guidance computers only had 72K kilobits of memory. Yeah, I've never liked these kind of examples. And what I mean by that is that I don't think using Apollo 11 guidance computers is a good example. What I mean by that is that, yes, the computers had to do things. They had to process math and they did complex stuff. They also had an operating system on there, but it was a real-time op and it had very few peripheral devices that it had to actually read from. So it's saying not including images. You can set up your website and all that and under that. But the Apollo 11 dashboard also was hard-coded. And what I mean by that is that there was a series of switches and stuff that you could play with. So it's not the same as a website. Websites have a whole bunch of extra stuff that they just don't have to deal with, right? There's input, there's things that you just don't even have to think about. And so I don't like those kind of comparisons because I don't think they're very fair comparisons. Now, I do think it's very fair to say that Doom had less lines of code than your React app. I think that is a very fair statement. Because then when people are like, well, my site's really complicated. It's like, yo, dog, they invented math that made 2D images 3D. So pretty sure it's also pretty damn complicated over there in the Doom world. All right, once you lose the auto-playing videos, the pop-ups, the cookies, the cookie consent banners, the social network buttons, the tracking scripts, JavaScript and CSS frameworks, and all the other junk nobody likes, you're probably there. I mean, you can have some JavaScript. You just can't, the hard part is the frameworks. That's really it. You cannot have React without it. But assuming you've tried your best to fit everything into 14 kilobytes and can't, the 14 kilobyte rule still is useful. True. If you make sure that the first 14 kilobytes of data you send to your visitors can be used to render something useful, for instance, some critical CSS, JS, and the first few paragraphs of text explaining how to use your app. By the way, we did, Guy, I even tried, he kind of motivated me to try to make a promise compliant library in one TCP packet. That was one of the things we were trying to do so that we could have really fast loading for certain things with the television, so that we could do some transferring. He was the one doing it. I was just I was LARPing along beside him, but he actually got me curious, so I went out and tried. It turns out it's really, really hard to do promise compliant stuff in under a kilobyte or in under 1,500 bytes. It's actually really, really hard to do. But I had to do my own special landing page, and I was trying to figure out how to do it on a TV in under one packet. It was actually super hard. Note that the 14 kilobyte rule includes TCP or HTTP headers, yep, which are uncompressed, yep, even with HTTP 2 on the first response, yep. HTTP 2 doesn't really compress headers. It's hard to call it a compression. I mean, I guess you can call HPAC a compression algorithm. It's more just, it's poor man's gzip. It includes images. Let's see, it also includes images. So load only what's above the fold and keep them very small, or use placeholder so your visitors know what they're waiting for. Or oh my gosh, it also includes images, so load only what's above the fold and keep them very small, or use placeholders so your visitors know they are waiting for something good. Yeah, I mean, 14 kilobytes in 2025 is dumb though. Why your first page load, sending down everything? Yeah, I don't understand why this is dumb. I gotta understand the argument for why it's dumb. Hit me why the stupid part. I am dead serious. I'm curious. Yes, you cannot base 64 encode your images into the first page load. That's what it means. So if you send down an SVG as part of the HTML, that's going to make the size bigger. You can load a whole hyperscript framework in that limit. It's called Datastar. True. Wait, so it's for the very first request like index? Yes, it's for the first request. Obviously, you put placeholders into things, right? You put placeholders into things. You throb them up so they vibrate. You don't need to load the whole framework. But here's the problem. is that if you do end up loading a whole framework, the site still takes a long time to interact. And so if you don't have a framework, you immediately make your site much more interactable. And if anybody's on bad connections, and remember, there's still whole parts of the world that there's a lot of internet packet dropping. India's a great example. There's a whole bunch of packet drops. And so it actually takes a much longer amount of time to send something over. Right? Why not have images that can be loaded only if clicked a button, a la Ajax? Well, you just have an image thing that requests the image separately and then have a nice little throbber box so it doesn't cause everything to disproportionately zoom out, right? 14 kilobyte rule is more like a rule of thumb than a fundamental law. Some servers have increased TCP slow start window to 30 packets instead of 10. Sometimes the server knows it can start with a larger number of packets because it used the TLS handshake to establish a larger window can be used. Servers can cache how many packets a route can manage and send more next time or on its next connects. Nice. There's other caveats too. Here's a more in-depth article. Okay, HTTP2 and the 14 kilobyte rule. This is an idea that the 14 kilobyte rule no longer holds true when using HTTP2. Obviously, that's not correct. I've read all I can about this without boring myself to death, but I haven't seen any evidence that servers using HTTP2 can stop using TCP slow starts to begin with 10 packets. Now, this one, yes. Let's see. Similar to HTTP2, there's a notion that HTTP3, this is what I said at the beginning, and Quick will do away with the 14 kilobyte rule. This is not true. Quick recommends the same 14 kilobyte rule. Oh, really? Is that true when it comes to UDP as well? Nice. Right there. Okay, interesting. So Quick has the same problem. Okay. I wasn't sure if Quick had the same. I wasn't sure exactly how Quick works or if it has the same problem, but there you go. I wonder if there's a world that exists where loading all these frameworks that we all use from content from CDNs as opposed to bundling them within your package in your like app actually would cause a speed up. Hear me out. Here's the reason why. This is kind of how I've always wondered this. I have no data to prove whether it does or doesn't, but like let's just pretend that everybody uses the CDN to transfer. We'll just call React because everybody's familiar with React. React, is whatever size it is, right? 20 kilobytes when it's gzipped, or maybe it's 50. I can't remember what it is. It's something small. It's not a bunch when it's gzipped and all that. But your browser could then cache that, and since the URL is going to be the same across all these different pages, or it will be some subset of being the same, theoretically, you could have all the modern popular libraries all cached on everyone's browser. We need to compress with LZM A2. Oh, why not LZ Ham, loser? After that CDN poisoning that happened, I feel like it would be a hard sell for some industries. Oh, okay, that's true. I'm just always curious about if that actually would make us would that make sense? DHH touched on that in your interview, didn't he? I'm not sure. Anyways, React is 40 kilobytes zipped. Okay, interesting. I didn't realize Quick had the same problem though. That's super cool. It just makes me want to build stuff and make the first page really small. It just makes me excited. How big is like the Phoenix app that you send down? Because that's something I have no idea. Right? Oh my gosh, look at how much CSS is sent down. I'm using Tailwind to be fair. Look at how much, wow. How's there that much JavaScript? Crazy. Look at all the JavaScript. Well, boys, looks like I'm exceeding it. But it does, to be fair, that does look like it's not minified. Okay, so we're not minified. All right, we're not minified, so that would make a difference. 910 kilobytes, that's like 15 Apollo 11s. Look like something is not going to make it. I'm not going to make it. We're not going to fit in. I didn't know that Phoenix was that big. Wow. Anyways, let's see. Okay, some caveats to the rule. 14 kilobyte rule is more of a rule of thumb than a fundamental. Oh, wait, we already read this. All right, further reading. Much of the content of the post comes from the following one. Let's see, high-performance browser networking. All right, increase HTTP performance by fitting the initial TCP slow start window. Critical resources. Okay. It's actually super interesting to think about. Like, can you make that first initial load super fast and the things you need interactive without all the JavaScript, right? I don't know. Let's do a little bit of a come to Jesus moment here. I mean, it did load really fast. Okay. I do have disabled cache, too. Okay, that was really fast. Hey. This is really fast. Dude, let's throttle it down to like some good 2G. Huh? What does good 2G look like on this website? Oh, that looked really good. Dude, that looked really great on 2G. Damn. Damn, that looks great. Well, the good news is we don't have to worry about that. I'm actually curious how much of this is actually real, in the sense that like how much production is actually slowed down by this stuff. And is there like a second start, right? You know how the slow start is like 10 packets? Is the next one 20? Or is it just like, you know, does it go way up to 50? Or is there like a stepping stone where it's like, okay, you can't fit in 14. Okay, the next best thing to fit in is within this size, which would be, what is that, 42? Wait, no, that's, I'm way off. No, I am right on. I'm right on. Approximately 42, right? Very curious. 14 or GTFO, I know. It's crazy. I don't know. Anyways, very interesting. Makes you wonder. If I build it, because a part of me wants to build, I want to do a little bit of a challenge with Elixir, where I just only do hand-rolled stuff, use no Phoenix, and build out a website for us to all interact on. I don't know. I think it could be really fun. Could I keep that under 14 kilobytes? I think I could. I'd have to be able to build an entire game. At my job, we have this rule to enforce on CI because the clients are often on broken computers or networks and packets dropped often, so it actually makes a difference. We have this rule. You have 14 kilobytes, JS14K challenge. Yeah, it's like a 14K challenge. It's kind of fun. I'm just curious what you could, like, yeah, the 14K challenge, because people do all this work to make all these different things, right? You play these video games. Someone made a Quake, right? What is it? Quake in 13 kilobytes. Look at this. So whenever you feel bad that your website doesn't load, oh my gosh, my keyboard's in Dvorak. Where is W? W. Wait, what? Oh, the directions are the, oh my gosh. Oh. Look at that. Oh, it's, oh my goodness, I'm not inverted, and I can't strafe. I can't strafe. Oh, can't strafe, it's like the old times. Isn't this crazy that this is 14 kilobytes? I mean, that's pretty good. That's like really good. Sorry, I played like a rookie. Dude, I had to use just these two keys to go up and down, and I don't have inversion. DEI? No. DIE. Anyways, very cool. I like that. I like that a lot. Okay, hey, the name is, if Quake can fit in 13 kilobytes, your marketing site should fit in 14. Get wrecked. A gen.